Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson on dividing exponents. So this is 7-4 in our textbook and in Math Excel. And this is dividing exponent properties. So there's a couple that we're going to look at. So first of all, here is our quotient rule, quotient divide. So if we have, again, we have to have the same base. So x to the a power, x to the b power, same base. So we will keep the base, and then we will simply subtract the powers. So a minus b. Keep in mind, these would then have numbers. So the reason we do that, if we look at this first example, and expand it out like we've done in the past videos. So x to the 5th over x cubed. So x to the 5th is x times x times x. So we can write it out, be 5 times all over x cubed. So 3 of them. So if we went through any value that we plug in for x, let's say 7. Well, 7 over 7, remember fraction bar means divide, that would be 1. So pairs of x's we can cross out and eliminate. So we can cross out 3 of those pairs and then see what's left. It'd be x squared. Now keep in mind, when we are canceling these out, they're actually becoming 1s. So like I said, 7 divided by 7, anything you plug in for x, it's going to be 1s. So all of those are 1s. So we'd have 1 left on the bottom. Well, that'd be the same thing as just x squared. So that is why we end up subtracting those. So if you ever get stuck on exponents and you don't know or you don't remember the rule, I would always expand it out like this. Or we could just use the rule where we keep the base, 5 minus 3, and we get 2. You get the same answer. All right? So here we know the rule now. So same base, keep it. And then 12 minus 2, we get k to the 10th power. This one, same base, keep it. 3 minus 3, we get 0. Now this is not simplified because we know the 0 power, anything to the 0 power is 1. So we'd simplify it to 1. And next one. Now, multiple variables, so we can only combine them with the same base. So we will keep the base a. 6 minus 2 is 4. And we do always have to do the numerator exponent minus the denominator exponent. Then also we have the b's that are the same, so we keep the base. Now 4 minus 3 is 1, but remember we don't have to write that power of 1 because it's not simplified. So a to the 4th times b. Again, same thing here. Our p's keep the same base. 7 minus 4 is 3. And then the q's also have the same base, so q, 16 minus 12 to the 4th. P cubed, q to the 4th. And now we have 3 variables, so pair up the common bases. 20 minus 5, so we have x to the 15th. Y, 9 minus 9, so we'd get 0. And then remember the bottom z here really has a power of 1. So we'd get z to the 1st. Now I know this isn't simplified, but I do want to show you this step. So anything to the 0 power, we know this is the same thing as 1. And then remember z to the 1st, we could eliminate that. So x to the 15th times 1, that y would completely disappear. It'd be gone since we know it's 1. So it'd be x to the 15th times z. All right. Now, let's look at some with coefficients. So, coefficients, we want to actually divide out the coefficients. If you can't do the numerator divided by the denominator and get a whole number, well, then you would just simplify the fraction. So we were either going to divide them to get a whole number or just simplify the fraction. And then you will look at the variables in that division and do exactly what we did in those top 6 examples. So I often like to show where we would forget about, and maybe if let's completely forget about those variables for a second and just look at 6 over 2. So we know that's 3. And then I would forget about the coefficients and just look at your variables. So 4 minus 3, so we just get 1x, and we just have 3x as our final solution. Again here, so 14 divided by 7, we get 2. R squared and r, so 2 minus 1, we just get 1r. I'm going to leave that exponent off. Same thing with our s squared over s. So 2rs. Next one, negative 36 divided by 4, so we get negative 9. C squared over c squared, all of that would eliminate. Remember, we could have it as c to the 0 power. We know that is 1, so I'm going to skip that step and just eliminate it. But d to the 5th, d cubed, so we would have d 5 minus 3 squared. So negative 9d squared. All right. Why don't we pause here and try 10, 11, 12, see if you can get those 3 correct. Negative over a negative is going to switch to a positive. 15 divided by 3 is 5. X's, so subtract them. We'd get 1x. I'm going to leave that power off. Y's, so y to the 5th minus y cubed, so we'd have y squared. And then we do have z left. And we can't combine that with anything because there's no z at the bottom, so it just stays as 1z. So 5xy squared z. Now, here's that example where oftentimes students see, oh, 8 and 4, and that's 2. But keep in mind, numerator has to divide by denominator, so 4 divided by 8 is not 2. So instead, I'm going to simplify this fraction to 1/2. Now, I always like to think about where are there more n's or where are there more variables. There's 5 on the top, there's only 1 on the bottom. So the n is going to stay on the top, and 5 minus 1, then we'd have 4. Now, I am going to simplify this because that 1 n to the 4th, we can eliminate that 1 and just do n to the 4th over 2. Okay, now you could also write this another way. You could write it as the fraction 1/2 and then put the n to the 4th like that. These two are the exact same answer. All right. And again, in this one, we cannot do 36 divided by 54 and get a whole number. So think about what goes into both of these. And actually, 18 goes into both of these. That's the greatest common factor. You may see, let's see, if we divide by 9, that may have been one you saw right away. So if we divide by 9, now you can see 4/6. We can simplify again to 2/3. So it's going to be 2 over 3. And if you would have divided by 18, you would have gotten 2/3 right away. M to the 9th, m cubed, so we subtract them. Remember, it is going to stay on the top of the fraction because there are more on the top. Same thing with your n. There are 3 more n's. Now, let's write this so that it's a little more organized. You can write this, again, in 2 different ways. So you could say 2m to the 6th n cubed all over 3. So that is one way. And I just rewrote it to make it a little more organized. Or you could also put it as 2/3 and then m to the 6th n cubed. Again, same answer. All right. Now, second exponent property we're going to talk about is very similar to the distribution one that we talked about already. So that power of 2 is going to go to the 3 and the x to the 5th. If the entire thing, let's say for instance that this whole fraction was raised to a power, then that 3 goes to every single thing, including the numerator, denominator, everything in there. So be careful, that's not the case here. So I'm going to get rid of those, but that is the second property where the entire division problem may be set to an exponent. So let's just do the top, because remember, exponents only go to what they touch. So we'd have 3 squared, and then remember here, it's a power to a power, so we'd multiply the 5 and the 10. And then that is still over 27x cubed. Now we would want to simplify. 3 squared on the top, let's simplify that to 9. So 9x to the 10th over 27x cubed. So again, we can simplify just like a normal fraction. 9 over 27 is 1/3. There are more x's on top, so we'd subtract those. So again, a couple different ways we could write this. I'm going to eliminate that 1, so we could write it as x to the 7th over 3. Or we could say 1/3 times x, to the 7th. 1/3 x to the 7th, like this. Again, same answer. Next one, again, this power on the outside needs to go to the 2, it needs to go to the a squared, and it needs to go to the b to the 4th. So very similar to the distributive property. I'm going to automatically do it right away. 2 cubed is 8. A to the 6th, because we're multiplying, and b to the 12th. I'm going to make sure that was a 4, yep. And that is all over for a cubed b to the 7th. So let's simplify. This is 1, 8 divided by 4, we get 2. Subtract, so a cubed, subtract again, b to the 5th. And we're just gonna do a couple more here. So 2 goes to the 4, goes to the w, and goes to the v. So everything on the top I'm going to leave. And the bottom becomes 4 squared, so 16. W squared, v squared. So 12/16. We can simplify. Both of those can be divided by 4. So we get 3/4. More w's on top, so w to the 7th, v squared. So again, let's clean this up a little bit. 3w to the 7th, v squared over 4. Or we can keep that fraction out front, 3/4, w to the 7th, v squared. Again, same answers. And last one, we're going to distribute this 4 on the top to everything inside the parentheses. So we get 2 to the 4th. 2 to the 4th power is 16. And then we get c to the 4th, d to the 16th, since we multiply. And then the 2 is touching that parentheses, so it goes to the 2, the c squared, and the d cubed. So 2 squared is 4. We get c to the 4th and d to the 6th. Now let's simplify. 16 over 4. We do get a whole number 4. C to the 4th over c to the 4th, so everything is going to eliminate there. And then our d is going to be to the 10th power when we subtract them. Okay? Now, there are a lot more examples on the back side. And actually, here is one of those examples that I was talking about, where the entire division problem has this exponent 3 outside. So it's all in parentheses. So that means everything inside this parentheses is going to have that power of 3. So it goes to the 2, the m to the 4th, the n squared, and then also everything in the numerator. So let's do this example real quick. 2 cubed on the top is 8. We would multiply our powers to a power. And then on the bottom, so 4 cubed, 4 times 4 times 4 is 64. And then we'll multiply that 2 and the 3, and then the n becomes squared. And now we will simplify 8 and 64 divided by 8, so it would simplify to 1/8. Then we would subtract the m's and subtract the n's. And again, I am going to clean up what I just wrote there. I'm going to get rid of that 1 out front, so m to the 6th, n to the 4th over 8 is one way to write the solution. Or write that fraction out front, 1/8, and then m to the 6th, n to the 4th. And you know what? I just realized I made an error. Maybe you caught it before me, but I kind of covered up that 3. So the bottom n should actually be cubed. So then when we subtract those, the n should be cubed. And I apologize. There we go. All right, I'm not going to have you do all of these because it gets pretty in-depth. If you want to use them as examples, awesome. Why don't you try out these 3, 18, 19, and 20 on your own and see if you can distribute that exponent. So 12 squared, we'd get 144 and k to the 10th. Then 15 squared, we get 225 and k squared. Simplify that fraction. You end up getting 16 over 25, and then the k to the 8th is on the top. Again here, so 4 squared is 16, a squared, b to the 4th. I'm distributing that 2 to everything. Then 5 squared is 25, and we get a squared, b squared. Again, went to all three. 16 25ths, we cannot simplify, so we're going to keep it. A squared, they're the same, so those are going to cancel. And then we'd get b squared on top, so 16b squared. I do not like using b because I think b often looks like a 6, so be careful. That does say 16b squared over 25. And last one, now we've got some multiplication rules that we've done in the past. 9 times 4, we get 36. X to the 6th, because remember there's really an x, one x there, and then one y, so y to the 7th. Nothing to multiply on the bottom, so then all we have to do is simplify. 36 divided by 6. Subtract your powers, 6 minus 2, and subtract your powers on your y's. So 6x to the 4th y cubed. All right. And notice those last examples, a lot of them are including all of the properties that we have learned, putting them all together. We have not learned how to add and, well, we have done some combining like terms with those last 4 examples. So